the last time that we had a class, we went into a discussion about correlation coefficient and being able to find our R value. Remember, our R value basically told us what determined a great line, or the closest to a linear line. An R value of 0.85 or negative 0.85, the closer it is to 1 or negative 1, the better line it is. If R is equal to 1, it's a perfect straight positive line. If our R is negative 1, it's a perfect negative line. So we're still going to be using some of the same tactics as before. We're still going to look at our correlation coefficient as well. But we're going to start finding what's called our line of best fit as well. So go ahead and get your calculator. We're going to go ahead and enter this table into our calculator. So if you forgot how to do that from last time, what we want to do is we want to go into Stat. And we're going to go into Edit, which it already has. Once you hit Stat, it's already in Edit. All we have to do then is hit Enter. And remember, we're going to put our X's in L1. So our X's in L1, our Y's, that one up there, here we go, in L2. So go ahead and take a second to do that. I'm going to do the same thing in mine. Now remember, if you already have something in your table, what you can do is you can use your up arrow key and you can scroll up to where it has L1 or L2 highlighted. Hit the clear button and then the down button, and that will automatically clear out your table. We can do the same thing with this one. So I'm going to go ahead and enter in my numbers. You should be doing the same. Alright, now once you have your numbers in there, we want to go back into Stat. And we're going to go to Calculate. And we're still going to go to number 4, linear regression. Now in the calculator it says linreg, which is exactly the same thing that we did when we were finding our correlation coefficient. And if your diagnostic is still on, you should still be able to find your correlation coefficient as well. So, like that. Now I'm going to clear this screen off, so if there's anything that you need from this screen in your calculator buttons, pause the video and go ahead and take a moment and get them down in your notes. Alright, so in my calculator, at the very top, once I found my linreg, at the very top it said y equals ax plus b. Below that I see an a value that's equal to 2. I see a b value that's equal to negative 3. I see an r squared that's equal to 1. And I see an r value that is equal to 1. Alright, so in this case I see that I have an r value. Remember, we don't need the r squared in Math 1. So I'm just going to go ahead and cross that one out because we don't need that one for now. But when we look at our R value is equal to 1. So that means that this was a perfect, straight, positive line. Okay, all of our data points lined up perfectly to make a straight line. Now, when we're talking about a line of best fit is the equation that your calculator is actually giving you at this point, which is right here. Okay, that's what we need. So we have this equation, we have y equals ax plus b, but what they're doing is they're telling us our a value. So what we really want to do when we write our new equation is take this a value and we're going to plug that into that spot, and we're going to take our b value, I'm going to pick a different color. Oops, I forgot to include the negative. It's negative 3, and for the b value. Okay, so your calculator is basically telling you at the very top it's y equals ax plus b. This is your a value, this is your b value. Just plug them right into that spot. So our line of best fit is y equals 2x, and you can put plus negative 3 or you can put minus 3. Both of them work. So that's our line of best fit. This one we have an r value equal to 1, so again, it's a very good line. Alright, so I'm going to go through and create another table. I'm going to make sure that this one does not come out to a nice perfect line. So if you need anything from this screen, go ahead and get it. I'm going to clear it. Alright, so I'm going to create a new table this time, and I'm going to make sure that this one doesn't come out to nice perfect numbers. So let's say this one's 4 or 5. Let's say 3, 1. Let's say -2. I don't know. Let's do -1. And let's do -5, -6. Alright, so again, I want to take a moment. I'm going to plug this into my calculator, so you should be doing the same. Go ahead and get your calculator. Go into Stat Edit. Go ahead and clear out the previous table. And we're going to put our x's in L1, put our y's in L2. Alright. So if you're still putting that in your calculator, go ahead and pause the video. But once I plug this in my calculator, I went into Stat Calculate. Again, we're going to go to number 4, our LinReg. And my calculator this time, again at the top is giving me y equals ax plus b. Below that I see a is equal to 1.0185, and there's some more decimals. I don't need to go any farther than that. It's telling me my b value is a negative, equals -0.25. Again, we don't need our r squared in Math 1, so I'm not going to worry about that one. It gives me an r value of 0.9448. Again, more decimal places, but I don't need to go farther. If your numbers are slightly different than this, but pretty close, I'm using my calculator from home, which is a little bit higher functioning calculator. Every once in a while when I'm doing lines of best fit, usually not with linear, but sometimes with some of the other functions, it's off slightly. I'm not using the same type as the one in the classroom, so it might be slightly different. Hopefully not. But again, from this information, we have an R value that's 0.94, which means it's it's positive, so this is a strong positive. It's not perfect, 0.94, but it's not bad. But what that means is my line of best fit then is y equals 1. Now you don't have to write all of these decimal places when we do these. Usually 2 decimal places is good. So 1 point, I'm going to say 0.2 x, and then minus 0.25. So that would be my line of best fit. Y equals 1.02x, again rounding about 2 decimal places, minus 0.25. Alright, so if you need anything from this page, go ahead and get it. We're going to do another example, but this time we're going to take it a little bit step farther. So if you need anything from this page, pause the video and go ahead and get that. Okay, so on this one we're going to look at, let's say, hours studied. So make a table for hours. I don't know why my U looks like that. And we're going to say our grade. So we're going to look at the table, let's say the number of hours that you studied, and then the grade that was received. So let's say if we didn't study at all, and we made a 62. Let's say we studied for 1 hour, we made a 74. Let's say we studied for 2 hours, and we made a 79. Say we studied for 3 hours and we made an 82, let's say. Okay, so we could go through, find our correlation coefficient, our R value. We could also go through and find our line of best fit, which we will. But often just finding the line of best fit isn't the only thing we're trying to do. What we're usually trying to do is we're also trying to use that line of best fit to predict something in the future. So let's say we want to find out what grade would we expect if we studied, let's say we studied for 5 hours. Okay, And that's supposed to be a question mark there in the back. But so what grade would you expect if we studied for 5 hours? This is another area that you can use your line of best fit. Is you can get kind of a trend equation that kind of flows with your data and then use that to predict something else in the future. So I'm going to go through, do the same thing with your calculator. Go ahead and take your calculator, stat edit, clear out the old tables, and I'm going to put my x's in L1, my y's in L2. Now this time it doesn't actually have x's and y's. So if it doesn't have x's and y's, which most of your word problems will not, the one on the left is always your x's, the one on the right is your y's. If it's facing long ways, the one on the top is considered your x, the one on the bottom is considered your y. So we're going to put our x's in L1, put my y's in L2, okay, so I'm going to stat calculate, find my line of best fit. Now in this one I'm not going to write everything that I'm seeing on my calculator. You should be able to find that. I'm just going to write out my equation. So my equation for this one would be y equals, it says I have an a value of 6.5, so 6.5x, and it says I have a b value of 64.5. And that is a 6 right there, and then it doesn't quite look like that. I have an r value of 0.95, so it's again pretty good. Not perfect, but it's pretty good. Alright, so we've got our correlation coefficient, we also got our line of best fit, and now we need to go through and answer the question. So with this one, if I notice, my x value was the hours. So what I'm going to want to do is I'm going to want to plug in this 5 hours, because that's hours in this case, and I'm going to be plugging that in necessarily for the x value. So y value is my grade, so the grade that I want to find is going to be 6.5 times 5 plus 64.5. And all I have to do is just plug that into my calculator, so 6.5 times 5 plus 64.5, and that gives me a 97. So if I were to study for 5 hours, according to this trend, this linear trend, I would expect to get about a 97. Okay, so this is one of the other things that we can do with line of best fit. You're going to see several of your homework problems asking you this as well. It'll go through, you'll have to find your line of best fit, and it'll say predict, what it would be for this. What you do want to make sure that you're careful of is you're not always plugging something in for x. It depends on your table and what you originally had. Our hours is what we were trying to find, for 5 hours, so we're going to plug in 5 in for our x for this one. There is one of them in your homework where you were actually plugging in the number in for y, and you have to solve for x, so just make sure that you're careful. If you need anything from this one, go ahead and pause your video. I'm going to clear it off. Alright, the last one that we're going to look at in this case is you may be asked to find your line of best fit from some sort of a scatter plot. So let's say, I'm just going to make one up. Let's say I have a point here that's at 1, 3. Let's say I have a point here that's at 2, 5. It's a 5. Let's say I have a point that's here. Let's say that one's at, I don't know, 3, 4. Let's say I have a point over here. If it'll let me draw it. Actually, I'm going to take that point off there. Let's say I have a point up here. I want it to look somewhat linear. So let's say this point's at 5, 6. Okay, so not a very pretty graph, obviously, but in this one, you can have a graph. You have one in your homework like this. It's computer drawn. You basically want to just go through and find your line of best fit from this, which you can. Some students like to go through and draw themselves a table. That way they can see the x's and the y's easier. It doesn't matter which order you put them in. So 1 goes with 3, 2 went with 5, 3 went with 4, and 5 went with 6. Okay. So now it's going to be a little bit easier to go through in our calculator and find our line of best fit. So to your calculator, we want to go ahead and do the same thing. I'm going to clear out my old tables. And find our linear regression. Alright, so for mine, I get a bunch of decimals this time. My R value is 0.83, so it's really not the greatest linear trend, but in this one, my line of best fit would be y equals, again, we only have to go about 2 decimal places. So mine says 0.6285, so I'm going to say 0.63, that'd be good. And it says my V value is 2.7714, so I'm going to say plus 2.77. So there's my line of best fit. Now, you may have a question that asks you guys to predict what it would be at 7. So basically, what is your y value if x is equal to, let's say, 7? Well, again, if we're going to make some sort of prediction, if my x is equal to 7, well, in this one, let me say, I'm just going to be plugging that in for my x value. So this one I would get y equals 0.63 times 7 plus 2.77. Try to put a decimal, there it goes. And all I have to do is just plug that in my calculator. So 0.63 times 7 plus 2.77. In this case, give me a y value of 7.18. So again, normally they're going to be in table form. They're not always in table form, so it could be in a graph necessarily. This homework does include some review questions as well, so some of the things that we've looked at in the last couple of weeks. I do want them to start staying fresh in your mind, so you may have to go back to those videos if you forgot how to do them, or go back through and look at your notes.